Hello and welcome. Have you ever thought about what molecules are doing all day? They aren't just static little balls and sticks like you see in a textbook. They are constantly in motion, wiggling, jiggling, and dancing in very specific ways. Today, we are going to explore this amazing molecular dance, which is called molecular vibration, and learn how we use a powerful technique called infrared, or IR, spectroscopy to observe it. To understand this, imagine that atoms in a molecule are like balls, and the chemical bonds connecting them are like flexible springs. These springs can stretch and they can bend. This is the essence of molecular vibration. There are two main categories of these vibrations: stretching and bending. Stretching is exactly what it sounds like. The distance between two atoms changes as the spring bond between them stretches and compresses. This can happen in a couple of ways. There's symmetric stretching, where bonds stretch and compress in unison, like they are breathing in and out together. Then there is asymmetric stretching, where one bond is getting shorter while the other is getting longer, in an out-of-sync motion. The second major category is bending. In bending vibrations, the length of the bonds doesn't really change, but the angle between them does. This creates even more types of motion. For example, there is a scissoring motion, where two atoms move towards each other, just like the blades of a pair of scissors. There's also rocking, where a group of atoms swings back and forth together. So, how does this all connect to IR spectroscopy? Well, every single one of these specific vibrations, whether it's a stretch or a bend, has a specific, natural frequency. It's like a tiny guitar string that can only play one specific note. Infrared light is a form of energy. When a beam of infrared light shines on a molecule, the molecule will only absorb the light if its frequency exactly matches one of the molecule's natural vibrational frequencies. When this perfect match happens, the molecule absorbs that energy and begins to vibrate more intensely. An IR spectrometer is simply a machine that shines a whole range of different IR frequencies through a chemical sample and detects which frequencies get absorbed. The result is a graph called an IR spectrum, which is essentially a unique fingerprint for that molecule. Because different types of bonds, like a carbon-hydrogen bond versus a carbon-oxygen double bond, all vibrate at different, predictable frequencies, scientists can look at the peaks on the spectrum and figure out exactly what kinds of bonds are present in an unknown molecule. It's an incredibly powerful tool for chemical identification. Thank you so much for watching. If you found this explanation helpful and want to learn more about the fascinating world of chemistry, please consider liking this video and subscribing to support the channel. Your support really helps us create more content like this for everyone. See you in the next video.